It is great to have everyone this morning. My name is Claire Sturm, and I'm with Wildfire Commons at the Societal Computing and Innovation Lab at the San Diego Supercomputer Center. And we are thrilled to be able to support this data workshop for Reboot the Earth Hackathon. Today, we're going to be covering a few things in our agenda. Getting into an introduction from Carla Padilla from UC San Diego's Open Source Program Office. We'll also have myself cover a little bit of information about the Wildfire Commons, which is going to be that core platform that you'll be using throughout this exercise. And then Pedro is going to give us a lovely tour of FireForge, which is onboarding area for this data challenge. And we are recording, so we're good to go there. And with that, I'll hand it over to Carla to introduce us.
Hi, everyone. Thank you for joining us. If we could go, yep, thank you. The next slide. All right, so I wanted to tell you about the United Nations and Reboot the Earth. So this Reboot the Earth Hackathon, that is a UN initiative. So they began it in 2019, and the first edition was held in Malaysia, India, Egypt, Germany, New York, Finland, and virtually. They had over 300 participants with all the different hackathons. And unfortunately, COVID hit, so they had to put it on pause, but they started it up again. The purpose of the hackathon is to bring together aspiring developers to create open source solutions that address climate change issues. Each hackathon focuses on an issue relevant to its location. So in some places, it would be dealing with drought, how to use AI to help manage your water. Other places, it could be like instability in the weather, like hurricanes or typhoons. Others, it could be getting your food to market because it's fairly undeveloped. On our next slide, it brings us to our hackathon. So our hackathon is going to be, it's the first hackathon that is going to be in Southern California. It's the Southern California edition. Its focus will be on wildfires. So the challenges you will get will relate to wildfires. It's a chance for you to collaborate with your peers to use open data and apply your coding skills to real world challenges. It's going to be here on campus at the San Diego Supercomputer Center Auditorium, and it'll be May 8th and 9th. Next slide. So the way it will work is that Friday will be the first day. At 9 a.m., check-in begins. You light refreshments. For those of you, typically we like people to work in teams. So we want people to either, start, putting together their own teams or meeting people, and we can help you form a team. Then we move on to the opening. We'll have a welcome, we'll do a keynote speaker, and we'll provide the challenges on that day. We don't provide the challenges earlier because we want to give everyone a fair chance to start at the same time. Working session will begin at 11 a.m. We will have mentors on hand, people who know the coding, know the data, AI, UI, UX, and Wildfire, etc. Now, some of them won't be available all day, every day, but what we will do is we'll provide you with their schedules on that day. We will have lunch. You will work through the afternoon, and then at 5:30, the first day concludes. Now, it doesn't mean that you have to stop working. You could go home and work some more with your friends, or you can find a different spot to work. But the supercomputer auditorium will be closed at about 5:30. Then you'll come back on Saturday. Next slide. Yep. Oops. I didn't write. I need to change that to Saturday, but it's Saturday. I didn't change the date. Saturday, May 9th. Again, we'll start at 9. You'll check in, light refreshments, and you begin working. There will be a pitch workshop because you will be pitching your solutions to the judges. So the people from the San Diego basement will be there to say, okay, it's going to be a half hour, tell you how to pitch, and then they'll be around to answer questions about your pitch if you have any. Again, we'll have lunch, afternoon session, and then at 2 p.m., we ask you to submit your projects. and then the judging will begin. There'll be 2 rounds of judging. First round is kind of the preliminary round. Will the finalists will be selected, and then there'll be winners, and then they'll do a final pitch to the final judges. For the final judges right now, it looks like we'll have 3 people from Qualcomm, one person from Microsoft, another person from SDG&E, and one more person from Cisco as our final judges. And then the winners will be announced. We will have a member from the UN there as well. Her name's Mitz. She's great. And I think that's all I have. Unless there are any questions about this side, about how the schedule works and how it will be done. I think I can turn it over back to Claire. So I'm just going to pause really quick. Do you have any questions on these 2 slides? Besides that, I got the date wrong on the second slide. Okay, it sounds like no questions. All right, so Claire, I think you can take over.
Thank you very much, Carla. So a little bit more about the platform we're going to be using during this hackathon. We have the Wildfire Science and Technology Commons, which has been this core space for open collaborations around wildfire resilient future planning. We've been doing a lot of work within this space to build out a really cohesive catalog of different data sets, services, model listings, and more that talk to past historical fires, services that allow us to understand fires, and then integrating those into workflows. And these workflows we have on our FireForge platform, which Pedro is going to give us a little bit more detail around because you're going to be actually utilizing them during this hackathon. Going into the why behind the Wildfire Commons, we can go into the next slide that kind of gives us a little bit of illustration of what we've experienced and what we know, right? We have this intersection between the damage we see and experience when wildfire is risking a community or natural resources that we need to preserve. Especially when it comes to tracking these fires, we have a lot of wonderful practitioners that are out there to make sure it's being managed. But there is this in between that exists today of not having the perfect set of solutions stacked together that allow us to do better planning when we need to control the resources so we have less fuels in the field that might enable a bigger fire to spread. And then also making sure that our practitioners, those firefighters that are out in the field, have the right resources for decision making when a fire is spreading. So next slide gives us a little bit of an opportunity for how can we connect the science and distill it into these frontline tools for our practitioners. And if we go forward, we have a bit of a vision here for the commons that I think we have you guys helping us enable as well. So how can we better utilize our data and science to advance what we call fire tech or these integrated solutions into real next steps for our community members, including those practitioners? So if we go next, what is in the Wildfire Commons? We have a couple of different areas that we're able to really work within. We have this community space where you will be joining as well as participants and members during the hackathon. But if you would like to build out your profile a little bit more about yourself, you can tell us what interests you have, especially around data, computer science, or any other areas of alignment here. This allows the community to get to know each other, get to know you, and if this is also a space you would like to continue exploring as a career, great opportunity for you to list yourself. We also have that community catalog that I mentioned earlier, where we have a lot of different data, models, services listed, and also a community marketplace. And this is elevating those listings for where we have services coming from folks in industry, folks in academia as full package solutions for you to start using. And then FireForge is this interaction where we're taking the data and pulling it into workflows so we can have these compiled services together to actually explore real results. So with FireForge, I'll hand it over to Pedro, who's going to take us into how you're going to be using this area of the Wildfire Commons for the hackathon.
All right, thank you very much, Claire. So, in this tutorial, my main goal is to illustrate you a little bit on how you can use this platform for the development of your solution, share with you some data sources that you can discover, how can you take advantage of the computing service that we provide via the Supercomputer Center, so you can have the necessary resources to interact with this data and start thinking about like the scope of solutions that you could develop during the hackathon. As Carla mentioned, we are not going to give you the prompt in advance. The challenge that you're going to be working with is going to be given to you on the very first day of the hackathon. But we wanted to give you some heads up with this platform so you have enough time to get yourself familiar with it, so you can start interacting with some data sets. And so during the day of the hackathon, you have an idea on how to discover data that is relevant for your project. One note that I want to mention is that the use of this platform is not mandatory during the hackathon. During the hackathon, you will be free to use any open source data set or any open source tool that you discover. But the reason why we wanted to give you this tutorial in advance is because this is work that we've been developing for at least a couple of years. There is a lot of expertise behind this platform. There's a lot of data. There are a lot of data sets that are actually used on field by the practitioners, by the scientists who are doing research around wildfires every single day. So we want to give you the chance to be connected to what we consider to be the best sources of data. But again, it is not mandatory. It is not your obligation to use this platform during the hackathon. Okay. So, what are we gonna cover in this tutorial? First, I'm going to cover how to log in and register to the platform. Then I'm gonna show you how to discover data, and I'm gonna give you some examples of relevant data sources that you could use for your project. But again, not that you have to use, but that maybe as you are thinking on your solution could become relevant for you. Then I'm going to show you how to launch a computing server on our platform. And finally, I will show you how you can collaborate inside of the platform, which can be useful for you not only for the hackathon, but eventually you get interested in this field, as Claire mentioned, you will continue collaborating with us or with some other members of our network of experts. Okay, so I'm gonna start sharing my screen for a second because I noticed that I'm only sharing the slides and not my full screen. And something that I also want to mention is that this webinar is being recorded. And so um, if during the process of replicating what I'm going to show today, you encounter any issues, please don't hesitate to reach out. The people who did not join the webinar live will be receiving an email from us with the details of the YouTube video. And so in that email is going to be sent by me. So you're going to have my contact information. So if there is any question or any blocker for you with the platform, like any issues with the registration or any issues accessing the compute, please let us know in advance so we can unblock you and you have all access ahead of the hackathon. Okay, so we're gonna start with let me see if I can get out of the screen. Yeah, I'm out now. So can you confirm, Claire, if you can see my full screen? Now I'm sharing the Wildfire Commons main page.
Yep, yep, we see the Wildfire Commons.
Okay, perfect. Okay, so The first thing that you will do is go to the wildfirecommons.org website, which is the main website where you will find all the information that Claire shared. And you are, of course, free to explore, to get to know our team, to know our partners, to know the community of experts around Wildfire Commons. Another thing that I would recommend you to do first is to click on this button, the documentation side. And in the documentation side, you will find more information about the Wildfire Commons. And also importantly, if this video or this tutorial leaves some doubts or questions for you, here you will find more supporting resources on how to get started with the platform, with the Wildfire Commons, how to sign in, how to register with some supporting videos. There is also a working tutorial in which you are guided step by step on how to start working with the platform, putting together your first what we call a workspace, how to launch the compute, how to explore data sets, and all kinds of resources. So it will be my first recommendation that as you arrive to the site, to first explore the documentation. Okay, to register and log in, you will find this button on the top right. So you will click on it. Then you will click on sign in with CI logon, and you will be redirected to this page. Now, here, for those folks who are joining from academic institutions in the United States, you will search for your institution. We know that we have a lot of participation from UCSD and San Diego State. So you will type here UCSD, that's my case, or you're gonna type San Diego State University. You're gonna select your institution. Let me get back to my case. And you're gonna click on remember this selection. For those who are joining from a private organization or are joining from an academic institution outside of the US, I know that we have folks from Tijuana, and we're very happy for it. Um, you're going to select Google, but when you or GitHub, whatever it's linked to your academic email, we want you to use your academic email for this activity. Okay, so if your academic email is linked to either a Google account, a Microsoft account, or a GitHub account, you're going to select it. You're going to click on remember this selection, and then you're going to log in using the credentials from your academic email. Okay, in my case, let me go back. I'm gonna select UCSD. I'm gonna click on remember this selection. I'm gonna click on log on. And this is going to redirect me to my institution login system. Okay, so in my case, I don't need to do it because I previously did that ahead of the tutorial. The only extra step that you're going to be required is that when you register for the first time, you're going to receive an email in which you're going to be asked to confirm your account. Okay. Once you verify your account, you will be good to go and you will be redirected to this page that we have over here. Okay. And so once you're inside of the platform, there are many things you can start working on. One of the very first things that you can do if you're interested in exposing your profile and getting and letting the community know that you are part of it and letting the community know about yourself is that you can edit your profile over here. You can talk about yourself. You can add your LinkedIn profile. If some of you already have some publications, you can also add your org ID. You can add your professional roles or your current internships, whatever you want the community to know about you, and most importantly, your expertise in software development, in data curation, machine learning, AI, whatever information that you consider relevant for the community to know about you. In my case, I'm the main expert within the team in everything related to data challenges, hackathons, and educational activities. Okay, so the actual work. Once you're inside of the platform, let me go back to my dashboard. One of the first things that I want you to do is to go to this left side panel and click on the community catalog. In the community catalog, you will discover all the collection of dataset entries that we have available for you. All of these data, or will say like the vast majority of this data, it's open, it's public, and there are a few cases of data that is not 100% open, but that it can be open by subscribing to a site or by creating an account with the relevant agency, or some private organizations that might have their data registered with us might be willing to share some of their data with students. Okay, so how do we explore data in this catalog? So the first thing to know is that the data is shown as it was registered. The data that you see at the very top, it's gonna be the data that was registered most recently. Some of these data, it's very specific to certain sites, but I will say that like these examples that we're looking at here, that these are three depth data sets from the USDS, this one corresponding to Alabama, this one corresponding to Arkansas. But the vast majority of the data here, it's general data, and each catalog entry presents resources in a different way. What do I mean by this? I'm going to explain in a second. So first, let's say that I want to explore data just from a certain organization. I can click on this button, and this will show me the different organizations that have data registered with us. So let's say that I'm interested first in discovering data from the US Department of Agriculture. So I click on search, and this will take me to the data sets that are part of this organization. In this case, we have 6. I can, for each data set that I'm interested in, for example, this is a very interesting data set, the National Agriculture Imagery Program. This is a collection of images of the United States in which we have really very valuable information about the ground and about our fuels that are on the ground. So for each data set, when you click on view more, this is going to take you to a dedicated page where you will be able to read all the metadata about this data set, when it was collected, what type of data it is, who is the creator of the data, what was the creation method, when the resources was last updated. And for each data set, you will find one or multiple resources. So for example, in this case, the first resource, it's a URL that can take you to the Air Explorer, and it has the instructions on how to explore, how to interact with the Air Explorer, and how to download the specific chunk of data that you're interested in. The chunk for San Diego, the chunk for California, depending on what you're looking for. And the instructions are here. Another way in which the data can be presented, for example, you can also get some resources like this, which is a script on how to do a bulk download to your local server. But in this case, you need to register for the USGS site. In other cases, the data might be also registered along with an example Jupyter notebook with base code on how to get access to the data, how to explore it, and so example on how to visualize it, how to start exploring it. And also in some cases, you might find direct download URLs that by the moment in which you click that URL, you will be able to download the data directly to your computer. Okay, so this is one example. Let's say that I want to look for a different one. If I want to go, for example, to the NASA data, if I click on NASA, this will take me to a collection of 47 different entries of data from NASA. This, for example, is a very interesting product that comes from satellite images. And again, if I want to learn more about it, I have all the metadata here. I have the description of the data here. And then when I click on the resource, this might take me to either a website, an explorer like the one we have here, or it can take me to a site to register and request some data, or it can take me to to download a resource to access the data. Another example that I can show you, we have also data from San Diego Gas and Electric, who are one of our main partners during this activity. And we have the fire potential index. We have their surface fuels. We also have, there was one that I saw very, very interesting. For example, this one is an index that they develop, which is how to understand better the Santa Ana winds, which people from California might be very, very familiar with them. And so again, we have in this case, what we have is an access to a repository with the data, host the different CSV files for the areas of the data and the temporal component. We can know when this data was generated, and we can know where the data belongs to. In this case, the LA Ventura area, the San Diego area, the Santa Barbara area, Orange Island. Okay. Um, if I'm not wrong, there was also another one around here with Santana Index that also had the original paper where with the publication of that index. But anyway, I will let you discover all of that. Okay, so you can search by organization. You can also search by a certain term, like for example, in this case, I'm going to remove the organization so I don't make a mix search between organization and relevant term. So if I search for the term station, this will take me to the different stations that we have. This can be weather stations, wind stations, NASA stations, everything that has the term station as part of the metadata. For example, this resource is a collection of historical weather data from 2010 to 2025 from 18 different weather stations. This is mostly from the Central Valley, but we also have these HPREN stations, and they have a sample for San Diego, and we also have the access to the raw sensors that collect this data every day. And another way in which you can also search for data, it's by the tags. Like most of these data sets are tagged, so we can search by the relevant tag that we are looking for. So I can search, for example, for weather, and this will take me to all the data sets that have the tag weather. Like for example, the San Diego Gas and Electric Weather Station wind gas forecast. And again, we have all the different historical data for this data set and the relevant metadata for it. Okay, so this is how you discover data in the data catalog. And like I said, uh, take the time to explore as much as you can. So far, I have shown you an imagery data set. I have shown you a weather data set, um, uh, a satellite data product, wind indexes, generated products from weather stations. So there is a lot of different data sets that you can use and that you can discover through the community catalog. Another thing that I will invite you to explore is the marketplace. In the marketplace, you will also find some particular products that are highlighted among our community. For example, let me share with you one that is very broadly used, which is Wildfire. This is another product from the Department of Agriculture, and this is basically a representation of all the different fuels, trees, shrubs, grass, everything that can ignite a wildfire. It is a representation of that across all of the US. And this is a product generated from satellite images. And again, as I mentioned here, these can have multiple resources, access to the main site where you can learn more about Landfire or whatever data set you're discovering. In this case, for example, it also has a link to the Google Earth Engine data catalog, so you can also access the data set using the Google Earth Engine library. And if you want to get to the Explorer, like you click here in where it says data, and it will take you to the different data access mechanisms that this data set have, either via their data viewer, like I'm showing here, where you can select the layers that you want to interact with, the specific gear, the specific area that you want to work on, etc., etc. So I'll let you discover and let you interact as much as you can with this. Okay, but as I said, it is not mandatory to use. You can also use other sources like the Earth Engine and any open data repository that you discover. But here we have collected a very, very comprehensive collection of data sets. Okay, so this is how you discover data. Now, how do you work with the data in our platform? We have a concept called the workspace, and the workspace, it's an entity where we let you put together entries from the data catalog and source code from open repositories like GitHub. So this can be connected and deployed on a Jupyter Hub service that we host in a national cluster called the National Research Platform. Okay, this is a computing service that has uh, a lot of nodes, a lot of computing memory and cores available for you, and that will let you interact with data sets that typically you won't be able to interact easily using your home laptop. Okay, so how do you discover some example data sets? Sorry, workspaces. If you click on the explore site section here below data challenges, you will be taken to all the different open community resources. This will show you the open data challenges, which I will mention briefly at the end of this tutorial. But if you click on this section workspace, you will discover some of the open workspaces that we have for the community so they can start interacting with the platform and how to work with within the Jupyter Hub service. I will particularly recommend you to go through this ALS and TLS data demo. This is a demo on how to work with LiDAR data, another very well used source of data in wildfires. And as you will see, this workspace has a very good description on what the purpose and the objectives of the workspace are, what are the instructions on how to run this workspace on our Jupyter Hub service. And as I mentioned, you will discover here the ALS data, the TLS data resources attached to it, and the source code that you will be using for this to interact with this data. Okay, so after you read all the instructions and read all the description of this workspace, you will click on this button called which says Add to my hub, and once you do that, you will click on this section called FireForge. And this page, your hub, will show all the different workspaces, the different projects, the different data challenges that are part of your user profile. Okay. In my case, I have a lot because I have collaborated and worked a lot in this platform so far. But here you will see this is the ALS and TLS data demo. When you first join the platform, you will only see the Scratchpad, which, as the name suggests, it's only a playground for you to launch a blank Jupyter Hub server and start just playing with the Jupyter Notebook and start playing with any data set that you discover either via the catalog or outside. Okay, so in my case, I can go to the ALS TLS data demo, which I added to my hub, and then I can follow the instructions. If I go to the bottom, I will see this button called the launch options, and this will show me the different computing launching options that you have available. The one that you're going to be using and for which we're going to be giving you access is this one, NSF National Research Platform. And when you click on it, this will take you to this page where you will be able to reserve the resources that you want to use to interact with your data set. Something that I'm seeing here, and this is very common, if this happens to you that that this section is not automatically populated with ALS TLS data demo, is because this session in the Jupyter Hub expired. So the easy fix for this is to click logout here, then click on back to the application, and then you will be able to select the project, the workspace that you want to work on. In my case, the ALS TLS demo. Okay. You will select the amount of resources according to the instructions or according to your needs. In this case, this is instructing me to reserve 2 cores and 32 gigabytes of RAM. Yes. And then in some cases, some workspaces that you will find might have some specialized libraries that you need to preload to your server. So the way in which you do that is by pasting here the corresponding image that the workspace requests. In this case, the instruction says, in the bring your own image, please paste this description, which is, for those who are not familiarized with containers and Docker images, pretty much it's like a pre loaded collection of libraries and packages that the data needs to be able to run. And the way in which the system recognizes this is because in some open repository, I stored all those libraries in a place called my user profile plus the name of those of that specific package of libraries. Okay, so after doing the reservation that the workspace instructs me to do, I will click on Start, and I will wait for the server to start. Something important to mention is that this is an open cluster that gets requests from the whole country. So sometimes you might take some time to get an allocation. It typically takes between 2 or 3 minutes, but maybe sometimes you might need some extra time. Okay, so while we wait, I'm also want to show you some of the other things that you can discover through the platform. We are always, for example, publishing open data challenges for the public, mostly addressed to students. And so you can also discover some of the previous challenges that we have hosted, like the Shrubwise Data Challenge, or we are currently hosting the Wildfire risk modeling exercise. Or you can also look at this example data challenge and onboarding, which is a replica of a data challenge that we hosted last year. And here you will be able to, if you join this, which is always open for everyone, you will be able to discover many other different data sources via workspaces that we prepared for the participants of this data challenge. For this data challenge, we provided with tree inventories from California, with data collected on the field from UCSD researchers. We also provided access to some artificial data via fast fuels, some national resources like TreeMap. So there are also lots of things that you can discover here. And in general, you are always invited to come to this section to keep track of the news that we publish and the events that we publish, and to participate in the data challenges that we made available via this page. Okay, so I'm gonna look at my server. Okay, it's still taking some time, and so that's one way to keep connected to the community. And so while I still wait for my server to start, I want to show you that here in your FireForge section, you can be able to create new workspaces for yourself. If you click on new workspace, this will open a template for you. So let's say that you want to call this workspace my hackathon workspace. You can provide a description of it. Once you have it clear, you can write the instructions. For now, they'll only need to initialize the workspaces by providing a title. So you click on Save Workspace. And then once you have your workspace ready, you can start adding assets from the catalog, either from here by clicking on the add, searching for the data set that you want to add, or if you discover it via the community catalog, you can, let's say that I opened this data set and I liked it for my workspace. I can click on add, I can click on workspace, and then I can select the workspace to which I want to add this specific data set. Okay. Also, if there you have developed some, let me see, where's my hackathon workspace? It is here. Like I said, I have a lot of workspaces. I can also add GitHub repositories to make it easier to connect the code to the computing server. And I can also add additional resources, which are basically URLs to relevant sites that I want the users of my workspace to have access to. And very important, how do I share these workspaces? Like if I'm working on a workspace and I want to collaborate in this workspace with another partner, how do I do that? Well, we have something called projects. And inside projects, you can create this space. Like this is one that I have with some of our NASA partners. And so here, for example, you can add members to that project, to a group inside of that project, and all of you can share the same workspaces. Like in this case, these are all the different workspaces that we are sharing, each of them interacting with different NASA resources, and each of them with its own data catalog entry and with its own source code. Okay? So this is still taking a little bit of more time that I expected. But I want to know first, before I continue, while I still wait for the server to start, if there is any questions so far of everything that I have shown. Nope, we're good. Okay. So okay, just so for demo purposes, let me show you the other server that you have access to. I wanted to show this one because this is like the most powerful one, but maybe you can discover this one on your own. Another one that you can use if you just want to have like a quick server to start working, to have a vanilla Jupyter Hub. We also provide this additional exploratory resource. And so this one will allow you to start a minimal notebook. This one should take faster to run because this is not requesting resources from a national cluster. But again, it can take a couple of minutes. But in any case, my point with all of this is that you will have access to this compute. Okay, here is the Jupyter Hub. Okay, so this is the minimal, but the one that I'm waiting for to start looks exactly the same. Okay, but the main difference is that this one has way more resources. Okay, has way more power. This is like the exploratory sample Jupyter Hub is mostly vanilla, easy to start server where you can just interact with some few cores and a minimal RAM for light data sets. But here you will be able to select the workspace that you want to work on. In my case, let's say that I select the onboarding workspace. Then I will be able to clone directly the source code that I have on this case. Didn't I think I have the wrong destination here. The source code that is attached to the workspace. You will be able to download the data sets that are part of the workspace and start working with them. Okay. Okay. This one is also starting. And so the idea is that you have access to this. So you have a playground to explore the data sets, to create your Jupyter notebooks, to have a the enough computing resources so you can work on your solution. Okay. Something that is very important that I wanted to share with you before stopping this tutorial is that once the Jupyter Hub server starts, which is now starting, okay, now we are in the main one, you will notice that you will have this user persistent storage self block directory. This is a user persistent storage of 5 gigabytes. Any work that you want to preserve across your sessions needs to be stored here. Okay? If you don't store your work here, the next time that you come back, once you stop your server, the next time that you come back, it will be lost. Okay, because these are servers that are temporary. Once you start working, everything is persistent during the session. But once the session stops, you lost your work unless you store it right here. Okay, and you have 10 gigabytes here of user storage. So the folder that you see here is the work that I have preserved across my different sessions. Okay. Also, when you start a project like the ones that I show here, when you create a project and you make a group of that project, this allows you to launch the project directly on the drop down menu that I show when you reserve resources. And this will grant you another extra folder along with this one, which will have the group name, and that's going to be a shared storage. That means that all the files that are placed inside of that folder will be accessible to all the members of your group. Okay? So that's another way in which you can collaborate and you can share files easily without the need of having to send emails or having to use your personal drive, especially if we are talking about big files. Okay? So coming back to the ALS TLS data demo that I have shown for these that I have used to launch this server. Again, the source code is here. Let's say that I want to persist the folder. So I move first to my user persistent storage folder so I can clone the repository directly inside of that folder and make sure that my work will be saved. So I'm gonna wait for the repository to be cloned. Now that it's cloned, I can access the folder of that repository. There is a notebook attached to it. And so that I can see via the notebook the characteristics of this data. If the folder, for example, had a requirements file with the Python requirements, there is a button here that makes it easy to install those requirements. And then from here, because this data is accessible programmatically, I can just run the notebook and start exploring the data source. In this case, this is ALS data. It's a collection of point clouds. These are collected via drones that take a landscape image of the ground, and then all these data is collected as points of clouds. And so this makes a very, very useful resources to classify fuels on the ground, to have a better understanding on how our environments are, what is the shape of our environment. Like here we have this nice visualization of how of a forest, and we can know the exact location of point. We can know the height of this canopy. We can know the color profile, trees, and between wood, and between grass, etc., etc. The final thing that I will ask you to do is that once you finish your work, because this is a shared resource, please be good citizens, click on Hub Control Panel, and stop your server if you are not actively working on them. Okay? So this is gonna be, as I said, a resource for you. You are gonna have the privilege to access this through between now and until the conclusion of the hackathon. And please, if you face any blocker or have any questions ahead of the hackathon, please let us know, because we don't want you to struggle or okay. And I'm gonna stop here the tutorial piece and get back to the slides just to show what are the next steps for you. And actually, I will hand this to you, Claire.
All right, great. Thank you so much, Pedro. So, just to pulse check, any questions from what Pedro has shared that we want to go through? Adi?
Yeah, thanks for that demo. I had a quick question that was for the duration of the hackathon, are we required to use this service at all, or is it purely there just as a resource to access data and experiment with it?
Mhm. It's not as strictly required. As I mentioned, you we are sharing this with you. There has been a lot of work put together to get these resources on a single place, and the data that we expose through this catalog and through this platform, it's data that is widely used in the wildfire community, among researchers, among decision makers, about official agencies. So you are more than welcome and encouraged to use the platform, but it's not mandatory. If you find yourself in a position to say, none of this is useful for me, it is fine.
I just want to add to that. This is Carla. Let me turn on my video real quick.
Mhm.
Yeah, you're not required to use this. If you have other sources, because maybe you're at a different university, they have something that you can use, feel free. We are trying to, we want you to feel comfortable with the data that you have. And we want to make sure that, we also recognize that hackathon is a short period of time. So if you're more comfortable with something else, you have data from something else, you want to use a smaller data set because that's, that helps you with your solution, that's fine. Again, everything here is provided as a resource, but it's not a requirement.
Great. Thank you guys.
Mhm.
Thank you. Any other questions from folks? If not, we can proceed with our next steps. So thank you to Pedro and Carla for giving us background around this hackathon. What we would like you to do next is, if you do choose to use Wildfire Commons, again, it's an available resource to you. Go ahead and set up your profile on the Wildfire Commons. You can access the link. I'll just do one more paste in chat for you all for a quick, easy access point. Once you've registered, do what Pedro was doing in the walkthrough, explore the platform, take an eye at the Jupyter Hub server, explore the data catalog. Really beneficial for you, especially during the hackathon phase. We'd also encourage you to look through the documentation, and if you have additional questions that come up, you're welcome to email Pedro and he'll get back to you. And of course, the most important next step, join us. Join us for the hackathon, May 8th and 9th, and we'll see you at the San Diego Supercomputer Auditorium for the event.